Okay, so for this section, it really 90% of the section is just remembering things about logarithms from college algebra. As you're doing this section, if you don't know how to do things with these logarithms, you need to go back to those videos that I linked in the section and watch those review videos on logarithms, okay? If you're curious about like, which one do I really need to watch for this problem, ask me and I'll say, hey, you need to watch this specific video. There's like 9 of them total or something like that. There's a lot of videos about logarithms. But if you're curious about a specific problem, what will help you, ask me and I'll refer to you there. Or you can just watch all of them, which is great. They are from last semester. Some of you took that last semester course actually for review. Anyway, here we go. We're going to start with the property. The derivative of the October, are you trying to stretch yourself on my side? She is. My cat here is clawing my side. Nice stretch. Anyway, the derivative of the natural log of x is the reciprocal of the inside. A lot of times I'm really going to say that, right? Reciprocal of the inside. Reciprocal means upside down. So it's 1 over the inside, which is just x. All right. We're going to use that property. We're going to do a bunch of stuff with logarithms. Here we go. Example 1. Find y prime. Part A, y is just going to be the natural log of x divided by the natural log of 3. Don't be fooled. Okay? I'm trying to fool you here, but I don't want you to fall for it. Okay? I want you to pass the test. We don't have to use the quotient rule here. Because notice that this thing on the bottom, this is a constant. It's an ugly number. The natural log of 3 is an ugly number, but it is a number. So I'm actually going to rewrite this function as 1 divided by the natural log of 3 times the natural log of x. A constant times a function. Constant times a function is a lot easier to take the derivative of because constants factor out in front. So y prime, that part, that constant's going to come out in front. All that's left is the derivative of the natural log, which we have a nice property. The derivative of the natural log is 1 over x. Simplify a little bit more. We'll have 1 over x times the natural log of 3. Or you could write the natural log of 3 times x, but it looks a little weird that way because the x is on the inside, or not the inside. If you're going to write it in the other order, what you have to do is the natural log of 3 times x like this. Either form is okay. Just be very careful that it's not just 3x. They're not both in the log. Okay, so derivative of natural log is the reciprocal. Let's use that again in part B. Wherever part B is. Y equals E. What? That's not this section, Jason. You tricked us. Oh, it all ties together. Last section as well. E to the 1 plus the natural log of x. Tie in the previous section, which is actually 2 sections ago, but we're skipping one of the sections. The derivative of an exponential function is itself. So the derivative is just going to be itself. Nothing changes with the derivative. Unless we have to use the chain rule. There's a whole bunch of stuff up here, which means we need to multiply by the derivative of the inside, which is the exponent in this case. Okay. So again, that first thing is just going to stay by itself. Nothing's changing. Derivative of 1 is 0. Derivative of any constant is 0. Derivative of natural log of x is the reciprocal of the inside, which is 1 over x. All right. We could write this a little bit differently if we wanted to. 1 plus natural log of x divided all by x. And there we go. We've got ourselves a derivative. Woohoo! One more. In a bit. Because I want to show you guys, there's another way of doing this. Notice that this function that we wrote is the same as this function, right? These y's are the same. Because if you multiply two e's together, You just add their exponents. Well, what is this? This is just e. E to the natural log of x are inverses of each other. The function is actually something really nice. It actually is just ex right here. So the derivative of this is actually just e. You might say, Jason, if you do this two different ways, how come you got two different answers? We actually didn't. This thing can be simplified more. I'm just not making you do it. Okay. If you end here, that's perfectly fine. But you can actually simplify this into something really nice, actually, but won't be making you do it. And just a comment that these are the same. Little bonus information for you guys there. Let's do part C. Y equals the natural log of 1 over x squared. Again, this can be simplified here, but I'm not going to be making you do it. The derivative of natural log is the reciprocal of the inside. It's 1 divided by the inside. The inside is 1 over x squared. So it's 1 divided by x squared. It's a complex fraction, fractions inside of fractions. But anytime you take the derivative of something, if there's garbage on the inside, you have to multiply by the derivative of the inside function. That's the chain rule. And remember, right, 1 over x squared, that's x to the negative 2th. We use the power rule for that derivative. This first fraction is the numerator divided by the denominator times the derivative of x to the negative 2nd, power rule. Bring down the 2, subtract a power. Right, the derivative of this thing right here is what we just wrote. Now in this first fraction, keep it, change it, flip it. Dividing by 1 over x squared is the same as multiplying by its reciprocal, which is x squared. The second thing becomes negative 2 divided by x cubed. And we can simplify a little bit. Right, we have an x squared, that's going to cancel with 2 of these, and we're just left with an x on the bottom. So after all is said and done, what are we left with? Negative 2 over x. The real superstar calculus / college algebra student would also realize there's another way of rewriting this function. Look at your properties of logarithms. Y is the natural log of x to the negative 2nd. Exponents come out in front of natural logs. We can actually rewrite this original function as negative 2 times ln x. Take the derivative. The constant doesn't change. Derivative of ln is 1 over x. And, oh! So again, you can simplify first if you're good with your natural log properties. I will not be requiring that though. There we go. Good luck. Have fun.